Hi folks, welcome back to one more Wednesday Hangout from B.net. As you guys know, B.net Wednesday Hangout is an initiative that we, as part of B.net community, we have started it from a couple of months. We get a speaker every Wednesday of the week, and we try to speak about a particular technology or a piece of information, and then we pretty much have 60 minutes of technical presentation while you have your dinner or whatever. So relax and enjoy a dose of technology is what the motto behind the Wednesday Hangouts. Today we're going to be having Mr. Arun Balachandran, who is actually who is an ex SharePoint MVP. MVP is Microsoft Most Valuable Professional, so he's an ex MVP. He's also a corporate trainer in the area of SharePoint 2013, 2010, SQL Server 2000 to 2014, data warehousing, and SQL Server BI. Today is going to be talking about caching in SharePoint Portal 2013. And over to you, Arun. Stage is yours.
Thanks a lot. Thanks. So we are going to be talking about SharePoint 2013 caching. So we have the agenda which goes something like this. First, we will be talking in general about need for caching and what is the implication of having a cache. Because all of us know that caching is important in terms of application. But some of you, based on the crowd, may not have worked with ASP.NET or whatever. We need to understand, first of all, the need of caching, application level caching, and what are its implication. Then we will see SharePoint 2010 specific caches, which is of course common to ASP.NET, and we will also talk about some common caches in SharePoint 2010 that we had. Then we'll be talking about the 2010 limitations in 2010 caching, because of which we come to a new caching that we need, which is distributed caching, which comes from the Azure framework. So we are going to be talking about distributed caching and what is it going to give us that was not present in SharePoint 2010 caching, and how is it going to help us in terms of increasing the availability of cache data as well as scalability. Then we are going to be talking about distributed caches in SharePoint 2013, which are again going to be common caches. Though I'm going to be talking about all the caches that are available in terms of enumeration, but I will only be discussing some of the important caches which are very commonly used, and then move on to the logical architecture of distributed caching, which means we are going to be talking about the cache farms. We are going to be talking about the servers which do have the caching, distributed caching services, each SharePoint server which has one instance, and how do we find out how many instances are there. Then we'll be talking about what do we mean by named caches, default caches. We'll be talking about what do we mean by regions. So this is more to do with the logical architecture of caching and understanding why we require these components called cache, named caches, default caches, regions, etc. Then we will be seeing how this particular distributed cache, which has this particular logical architecture, is going to be implemented in SharePoint. So we are going to be talking about that. Then we are also going to be talking from an admin angle. So if you look at this entire session of distributed caching, we will not be looking at distributed caching from a developer perspective, though we should know from a developer perspective what is the benefit it's going to give us. It is more from an admin perspective as far as settings are concerned. So we are going to be looking at what are the different parameters we set at different levels. For example, what is a parameter that we are going to set at individual computer level for caching? What is the parameter we set for the entire farm? What is the parameter we set for the cache itself? So these are the different options that we are going to discuss. We are going to discuss how caching is managed by SharePoint in terms of if the cache gets full, what is the algorithm that's used, and what is the logic behind using the algorithm, etc. So that's what we are going to see. Under other considerations, we're going to look at how else can SharePoint caching or distributed caching help SharePoint. Now we need to understand that distributed caching as such is implementation specific to Azure, and not all of its features are utilized by SharePoint 2013. For example, distributed caching allows you to create a custom cache. So as of now, SharePoint 2013 does not allow us to create a custom cache. So likewise, we have other considerations that we should be talking about. And finally, we end with a small demonstration in terms of where do I go and set. So it's a strict no-no of setting anything with respect to distributed caching and using the user interface. So it has to be done through PowerShell. So we'll take a look at certain PowerShell commands that are important and what they mean to us. And we'll also look at the configuration database, which is going to be giving us some information about distributed caching. So next, so the first thing that we have to understand is why is it that we have caching in place? So all of us know, most of us who have worked with applications know the reason why, but let me still go about it. So the first reason is I may be required to pick up data from a place which is connected to the application through network. Now, if I have to pick up the data very often, I do not want network latencies or delays. So it's better for me to cache the information at my application level so that there is no network latency or delay. Now, this can be data that is coming in from another application or a service, or it could be data which is coming from a database. So either ways, we require to actually reduce the latency and delays. So that's one of the reasons we go in for caching. Second is at certain places user mediations would be required. So we want to reduce user mediations. Typically, for example, when you log into an application, the application uses your username, password, provides a token to you, and that process completely is long. So now just imagine a user is creating a session with the application, and for every request he has to go ahead and look at the token or create a token all over from scratch. It makes no sense. So I require a caching mechanism to have all the user information cached so that it can be utilized for all the subsequent requests. So that is what we mean by user mediation required. So if no caching is there, every time I establish a request, I allow to go in for user mediation, something that we don't want to have. Next, there are certain places where processing power would be required, which means, for example, typically in ASP.NET, creation of page or the page lifecycle itself has a good processing power that we go through in terms of CPU. Now, every time going through the processing power makes no sense. So what I would like to do is, if everything is going to be common, if I'm not going to be changing my controls, if I'm not going to be recreating my controls every time there is a page refresh, I would actually go in for caching information that is being processed by my CPU. So I want to reduce my CPU processing every now and then. That's another reason we go in for caching. Then the next reason could be, my authoritative sources are not constantly available. So what do I mean by authoritative sources? For example, databases. So I'm connected to the database, which is the only source from where I am getting authoritative information. But I may get disconnected to the database because of poor connectivity, or it may be that the database is going to be too busy, so I am not going to be always connected to the database. So either of the reasons, we may not have authoritative source available constantly. So these are the few reasons for which we opt for caching. So all of us know, those of you who have worked on ASP.NET, you have ASP.NET caching. If you create a custom application, you can create cache of your own. So what are the implications of caching? Which means, fine, caching solves certain problems, but it is something that we need to trade off if we have to look at what is the problem that caching is going to have solve. So when you look at it first, what are we going to do about the currency of the data? When I say currency of the data, how latest or how recent is your data? What is the length of time for which the data should be relied on, after which the data should be refreshed or the data should be created again? So when should we bypass a cache? So at certain times, even if you have data which may be the latest data, relatively the latest data, I may not require the cache. I may require to bypass the cache and directly use the authoritative source. So that could also be done. Then when should I be using the cache? So these are some of the things that we look at when we talk about currency of data. Then The next thing that we look at is, fine, I have cached my data, but what if I lose the cache data? So which means if I'm going to be losing a cache data in terms of one particular server is down, then I connect to another server. For example, when we go for IIS, we have a server farm, we have a web farm. I connect to one of the servers, then I'm going to basically look at accessing the data, and after some time that server is not available, so I'm going to access another server. So what are we going to do? Does it mean that I have lost the cache data and I have to again go and fetch the information from the actual authoritative source? So that could be one of the things that we have to consider. What if the data is lost? So are we going to have secondary copies? Are we going to make the data which is a cache data highly available? So it's something that we need to consider. So these are some of the implications of caching the data. Now we are going to look at what are the typical caches that are available in SharePoint 2010, that is the previous version. So typical caches available was basically a blob cache. So all of us know that in SharePoint we have the document library, the picture library, and all of the libraries that we talk about. So typically libraries, document libraries and picture libraries store huge documents which are equivalent to blob. So in this example, basically we use a blob cache to avoid network latency because we are retrieving huge amount of data. So if I want the same document again and again, or it's going to be accessed multiple times, I better bring that particular document from the store into my application server, which is what we mean by blob cache. Data could be stale, so we need some mechanisms. So mechanisms were there to deprecate and say this data is stale and we will have to get a fresh data for the blob. The other feature that you can see in a blob cache is the blob cache was local to web server, which means typically when you look at any web server or server farm, this is for the sake of people who are may possibly be new to the web server scenario or the server farm web farm scenario. So if this is my web farm, so I'm going to be having multiple servers. So typically each server is going to be looking at a particular request from the user. So user is in here, and then I have a router typically that comes in handy, and my sessions are managed by this router. So my request is going to go to any one of these servers. Now the question is, whenever my request is going to go to one particular server called server 1, this server is going to take care of getting to the database, picking up the blob and caching the blob, which means it is a server caching and it is not caching at a farm level. So when you look at this entire farm and you say I have 3 servers and I should have a common caching mechanism, something that could be implemented but it was not available out of the box in SharePoint 2010 is something that we need to understand. So hence every time I go to a separate server, it was difficult for me to get the data. So what they usually did was they had something called as sticky session, which means I should be sticking to only one of the web servers so that caching helps me to get the information. So in order to help caching, we use the sticky section mechanism. So as we said, the blob cache is local on each web server, which means a web server changes, the blob will have there will be no cache and the data will have to be fetched directly from the authoritative source. So in this case, the authoritative source is typically a content database from where you would be fetching the information. There is no high availability. So if something happens to one of the web servers and if I am forced to change my request, or my request goes to another web server through the router, I have no chance of having the same cache available because it is not designed in such a way. So when you look at this blob cache, for example, you have certain good things that have come out of it, but you still have certain limitations with respect to 2010 blob cache. So if you look at blob cache comes up with a scenario of I want to avoid network latency. So look at the first point. So we have already discussed one of the things for which we use caching is basically to avoid network latency. The other thing we said was we want to use caching to avoid processing power. So this example that we take is that of the ASP.NET page output cache. which typically worked for a publishing page in SharePoint 2010, because there was no recreation of a control, and control behavior was very limited to editing and display. So that behavior was controlled mostly through declarative means. So you really didn't have to force yourself much. They used page output cache usually with the publishing page. Again, the reason why they use the page output cache is we wanted to avoid the processing power which was repeatedly taken care of. So SharePoint had to go take a look at the page. So we know the entire scenario if you have worked on SharePoint. If not, I'll just quickly talk about it. So we would typically be using first, whenever a request comes from the user, I'm directly going to show you a server here. So the request comes to the server. The server actually goes to the database first to fetch the page layout. So what I get when we talk about the first instance is the page layout. So I'm going to call this as layout. So PL, page layout. Now, once the page layout comes into the server, which is your SP server, I'll call this as SPS. What the server does is going to do the processing. So as it does the processing, the page layout is in the content database. If you have customized the page, sometimes the page layout could also be in the file system. So that depends typically on the page. So what you will notice is SPS has to either fetch the page layout from the file system, or it has to fetch the page layout from the custom DB if it is customized, or the content DB if it is customized. After fetching, the processing happens. So this is the processing that I'm just showing you. So once the processing happens, obviously during the processing, I'm again going to be accessing my content DB for the actual content that needs to be displayed, getting back the content, and then finally displaying the page to the user. So this is what is happening every time a SharePoint page is going to be displayed. It's a two-level of access. One is accessing the page layout. So that is point number one, accessing the page layout. Point number two, accessing the content inside the page when page processing is going to take place. So it's a two-step process. So obviously this two-step process has a good amount of processing power at the server side. Now you don't want this processing power to be unnecessarily repeated when you're going to get the same page. So you don't want that. So ASP.NET Page Output Cache was implemented, which was carried through in SharePoint and used by SharePoint. Now basically when we talk about this page output cache, there were some issues which needed to be solved in terms of the data in the page could be stale. So which means you may not get the latest information from a list or a library. So we had to take care of how often should I refresh the cache. Then data could also be inaccurate for a given context. Like if a user is different, automatically if the target audience is different, I really cannot use the same page in order to display the information. So that also needs to be considered. Apart from that, whenever we talk about the page output cache, we had to have good usage of RAM. So which means we have to either go in for good RAM, or we had to go in for a very fast processor. So that's again a trade-off that we do when we talk about the page output cache. The next cache that we usually had was basically we talked about service property caches. So you had multiple services in SharePoint. One of the basic service was your user profile application. So we had lot of information as part of user profile, like my site URL. Then we had the user profile synchronization in terms of getting the information from your Active Directory and syncing it with SharePoint. Then we had newsfeed settings that are coming up. So there are various places where the information had to be cached. And usually these cache settings were present as part of user profile application. You had the proxy settings, you go to the proxy settings, and you would actually be processing the cache or using the cache. Now the cache that we are talking about, which is a user profile application cache, was process specific, which means you had the cache for every W3 WP process that was created in SharePoint. So if I have a site, and if the same site is having two W3 WP processes running, or for every site or web application, one W3 WP process is running. Per process, you have this cache, which means if the same profile information has to be shared across multiple applications, web applications in SharePoint, we had no choice of doing it. So which is what we see very clearly when we talk about the user profile proxy setting caches. Then we had one more cache, which was called as the object cache. So as usual, we actually didn't want good processing power as well as latency to be there, repeated again and again. So any query that goes to SharePoint in terms of its list objects, in terms of document libraries, in terms of sites, the query results could be stored in SharePoint objects. So that was very much possible. So this had one limitation with respect to not getting the latest information. Okay, we could also use object cache to do cross-list querying using the SP data query object. So this is something that we can do in terms of object model. So this is what we mean by object caching. Again, this was also a good method to do caching on the client side as well as the application server side. This was basically not only caching the query related results, it was also caching frequently accessed objects like frequently accessed sites, frequently accessed user information, frequently accessed lists and libraries, frequently accessed page objects or web part objects. So these are the things that were usually cached when we talk about SharePoint object cache. So to summarize what we have covered so far in terms of caching in SharePoint 2010, these are the different caches that we have. We have the cache, we have the authoritative source, right? What is the resource we are conserving by having the cache, and what is the location of the cache is what we are going to be talking about. So when you look at a blob cache, typically a content database is the authoritative source. The conserved resource here is the SQL request, which means SQL is unnecessarily not going to get blocked every time I ask for some document, right? And the location where you're going to store this document or blob is a web front-end disk drive, which is the data location. It is not an in-memory location, it's a disk location. So which means it's a hard copy of the cache and not the soft copy which is available. Then ASP.NET page output cache processed using ASP.NET requests. So the authoritative source is going to be ASP.NET, which is present in your server, web server. What are we trying to conserve here? The conservation that we are trying to do is we don't want to use the CPU on the web front end too much. So what we do is we cache the output of the page. Where do we cache? We cache it in process memory. So web process memory is what we talk about. So again, remember that the page output cache is only available for a particular web process, and it is available on a web front end. So if I'm going to change my server, obviously the cache is not going to be available. Similarly, when we talk about UPA setting caches, the user profile application web service is responsible source from where you get it. Ultimately, it gets the information from the user profile databases. So all of us know the different user profile databases in SharePoint 2010. Then we talk about the WCF request. We are trying to conserve going back to web service every time. So that is the conserved resource. So again, you're trying to reduce the network traffic. And again, you're going to be caching it as part of web process memory. Web process memory means it is cached inside the process and it is going to be in-memory cache and it's not a disk drive cache. So these are the typical things that we look at. As far as object cache is concerned, we are again looking at object cache in terms of SharePoint. So you have a SharePoint object model. So when you look at the authoritative source for your object cache, it is going to be SharePoint web service, or so the authoritative source. The conserved resource for the cache again will be the usage of the network, and again the cache is going to be for every process and per memory. So that is your cache that we look at. So now when we are considering cache storage, what do we look at? How do we optimize and find out where do we need to store? So we have two options. Either I store it in the central location or I store it in the local location. Now storing it in the central location, obviously your latency is going to be a little greater, which means if I store all the cached information in one place, every web front-end server will have to go to individual the common source of cache and pick the information, which means there'll be some latency. Local cache, the latency is reduced, but remember that the availability is also reduced, whereas in central cache availability is going to be very high. So the first thing that we look at when we talk about optimization, what are we trying to optimize here? Are we trying to optimize availability here, or are we trying to optimize the latency? Sometimes it's also a combination, which means the cached information is present in the central location, but secondary caches may be present in the local location. If the secondary caches get expired, then automatically I fetch the information from central location. So I have a combination also that comes into picture. The second level of optimization that we do when we talk about caching typically is who is going to be accessing the cache. So when you talk about scope of access, it's not scope of storage. That has to be clear. Scope of access. So which means when a cache is created, can all my processes access, or can only some processes access? So typical example is an ASP.NET cache. A ASP.NET page output cache, only a process can access it. Another process cannot access it. Similarly, when we talk about service level, so which means only my service is going to be accessing the cached information. Other services will not be able to access. So typical example is a user profile application setting that we had in SharePoint 2010. And then we have the server blob cache, blob cache, which is at the server level. So you will notice that although we are storing user profile application settings for in memory for every process, it can be accessed only at the service level, which means tomorrow if you're going to create another user profile application settings, obviously the cache is going to be out of scope. Similarly, for a server, blob server is the access, which means if I change my web front-end server, the cache is no longer going to be useful. So these are the things that were there in 2010. They did make our life easy, but obviously we are not happy with what we have. So technology is constantly changing. So limitations that we found was scope of access. Literally, I can't say that a page output should be available only to a particular process, or object caching should be done only at a process level. So scope of access clearly had to be widened. So that was the first limitation. Scalability was not happening, which means if my cache is going to be available only in one system, I will not be able to scale to a large extent, which means multiple people may not be able to access the cache. So cache scalability is not there, obviously. Availability is not there because cache is available only in one place, which means if the cache goes off, I will have to go and get the data from the authoritative source. Redundancy, there is no redundancy in cache data, something that we look at, which is amounting to availability. So if there is no redundancy, there is no high availability. Performance also was less because when we talk about caches available only in local places, every time there is a problem with respect to the server, we'll have to move and get the data. It was local, latency was still there. We didn't know, we could not get the matching data. So if I get the data from one web server, I may get a separate data because the cache is not refreshed. Whereas I get a data from a new web server, cache is refreshed and I get a information. So all of this comes to a point wherein I have a new concept coming in called distributed caching. Before we move on to distributed caching, let me just quickly talk about what we mean by distributed caching. So distributed caching meant what we usually do for sessions which are common. Like we talk about not having sticky sessions, having common sessions. So in short, what we are trying to say in here is basically we are going to have a farm, and a farm contains the web front end, and it also contains, so when you talk about a farm here, let's assume that this is my farm. Okay, so my farm typically contains a web front end server. or it can also contain server which is going to be application server. So typically for your search application kind of stuff. So you'll also have application server. So now what they decided to do was, instead of having cache at different server levels, they introduced a service. So this is my distributed caching service. Let's assume that this is my distributed caching service. And as we know the service application concept, you can have any number of instances of the distributed caching service. So I'll call this as caching service CS. Now this caching service is something that can be implemented at, let's say, web front end you have 1, 2, and 3, and application server you have 4. So total, let's assume in the farm we have 4 servers. You could have this caching service implemented as part of 1, 2, 3. Of course, the instances will be separate, and you may also decide to have 4 also coming into picture. So all these 3 would actually have different instances of caching services running. So let me quickly show you an example here. This caching service we decided was to have a Windows Server App Fabric cache. So let me go back and go to services window in my server. So this is my server that I'm looking at, and you move on to the server services window. Okay, mine is a single server farm. So although we say the distributed cache works for the entire farm, because mine is a single server farm, I will not be really able to demo anything on distributed caching. So this is more of a demo on, what is available in terms of services and stuff like that. So okay, now it's taking some time. Nevertheless, I can show you as part of this application management. So you have managing services on server, something that we can look at. So let me go to managing service application, manage services on server. So you can see that I have only one server. When you look at the entire farm of SharePoint, in my farm, I actually have only one server. And this server, you can see that there's a distributed cache which is going to be running. So let me just quickly go to looking at services on server. Okay, let's directly move on to the. I'm just showing you this one single server, and you have this distributed cache service which is running on the server. Let's remember, though it is available here, very clearly, please do not stop it from in here. So we will be looking at some repercussions as later in terms of what should be done, what should not be done in terms of managing the distributed cache. So what I wanted to talk about is, if I have multiple servers in the farm, every server can actually run this distributed cache and can have multiple instances. Okay, so what we will see now is very clearly, you're going to be having multiple servers in the farm, including the web front-end servers and the application servers, and you'll be having cache service instances which work for different servers. So that's the idea of distributed caching. So what was the need for distributed caching in short? So widely accessible, which means I should be multiple processes should be able to access, multiple servers should be able to access the data. Storage is centralized across servers and across processes, which means you're going to be having one storage. Scalability is something that we are clearly looking at. So whatever was the disadvantage of an individual cache, now it's going to be we are trying to dispel it. Availability, redundancy, performance is what we are looking at. Okay, now the next. Distributed caching is a concept that is used by Windows Azure. And how is SharePoint going to make use of this cache? So SharePoint is having certain areas where it is going to make use of this cache. Can we create a custom cache? Yes, actually Windows Azure distributed caching allows us to create a custom cache. But as far as SharePoint is concerned, that particular option is disabled. So SharePoint specific implementation of distributed cache does not have an option for, as of now, creating a custom cache. So let us look at what are the areas of SharePoint for which you would be creating caches. First is the activity feed. So to explain this concept of activity feed, let me quickly go through the social data concept. So we all know that there is going to be a personal area for every person in SharePoint, and this personal area is going to be called as my site. Okay. So we are also going to have a common area which is going to be present as part of the team site. So something that we should know. So this is my common area, which is the team site, and this is my site. So now there are a lot of activities that are happening in your team site, and a lot of activities happening in your own site. So take consider activities. Let's assume that your site is your area, something like your house, and the team site is a common area which is open to public. A lot of things are happening in the common area. Lot of things are happening in the home front. So now there has to be some mechanism to synchronize, or as a person who is owning the site, who is owning my site, I should be able to access information from my site. I should be able to access information from what is changed uh, into the common site, as well as if some other user has his own site, I should be able to access his information as well, which is public, which means there are certain things that you would like to share with others. So what is this concept of activity feed? Activity feed is a store of activity which is happening at the team site level, for your own activity which is being stored, activity of other users which is going to be stored. So you have site feeds, you have user feeds which come into picture. Again, user feed is distributed as feeds related to you, feeds related to activities that's happening or is done by the other user. So you have user feeds and site feeds that come into picture in SharePoint. So activity feed basically is about the activities that are happening at the user level and the site level. Now, why caching is really important? Because there are too many sites that are there which you may be a member of. Now, you may want to know the information from different sites. Similarly, there are too many users, whose activity is something that, keeping track of them, when especially you're connected to them, it's going to be a little tough. So activity feed is an absolute essential. So SharePoint has recognized that as an area. Then you have another cache which talks about the latest modified time for the activity. So you have the activity LMT. Logon token, that's because in 2010 they found out that user is logging in, and you have the concept of claims authentication, token coming back to the user and user using the token. Now instead of generating the token every time the user is trying to access, the token can be cached. So which means every time the user is going to access, the next request that comes from the user directly uses the token which is being cached, not at the user level, but the caching is done at the server level. Okay, server to app server access token, which means 2013. If you all have worked with it, know that they have introduced the concept of apps. So app also require token. So whenever an app is accessing, the app server access token also has to be cached. So we talk about caching that. View states are cached. So you will notice a big difference. So far, view state is being sent from the app server or your web server to your browser, and your browser sends it back in a hidden variable. No longer going to happen in 2013. The view state is cached in the server itself. Of course, there are advantages and disadvantages. If I have to access anything from the view state, I basically have to access the cache. Right? So you can switch it off when you need, when you don't need it. When you need it, you can switch it on. Search also is one of the areas, because search is very big in 2013. If you all have gone through the introduction of 2013, you will notice that search itself is a application which is being used by multiple other applications in 2013. Like it is used for e-discovery, it is used for your social data, etc. So search is a very big area, and caching is essential. Security trimming also can be cached in terms of when a user logs in, what are the actions he's allowed to do, what are the actions that are available to him, not available to him. So given a page, security trimming also needs to be cached. Then we have access caches, so which means we are talking about the access service cache. Then we have something called bouncer, which is related to accessing information from different servers. So these are the different caches that we have in SharePoint 2013. Now all these caches are created in SharePoint 2013 by SharePoint architects who developed SharePoint as a product. Apart from this, can we create a cache for some specific area? If you ask me, Windows Server allows that to be done, but SharePoint has not exposed it to you. So which means you will not be able to create as of now any custom caches. Okay, so then of course you have a default cache that we look at, which is the basic cache that we go back to in SharePoint 2010. So just to explain logon token cache, so prior to 2013, this was a server local cache, which means there was a performance hit. I could not go across different web servers. When I log in, I'll have to stick to only one web server per session. So it led to sticky sessions. Otherwise, you had additional user prompts. And we know if we have your Windows Server Federation, we are going to be looking at going to every login, going through the pain of multiple logins. We do not want that. So that was a problem. So distribution cache basically ensures that you don't stick to one particular web front end, but you're able to access multiple web front ends. Similarly, we have something called as complementary lock token caches, as I told you. So we can have a distributed cache where you have the lock token, and you can also have a reference to the distributed cache lock token in your local web front end. But those are weak references, which means it can get exhausted and you may have to go back to the distributed cache. But they have a complementary cache as well. Then you have view state caches. So which means, as I said, the cache, the view state is going to be stored on the server side. So in case you want to access the view state, you can access the cache. Okay, so GUID is given to the client, using which the client is going to access the information. And we have a cache which is governed by a specific web service and a property. So this is a typical example. In a 2010 page, when you look at the view source, you will be looking at the view state, which is having a lot of information. And in 2013, you will notice that the view state is going to be replaced by a GUID. And the GUID is going to be accessed whenever required, whenever the view state is going to be required. So this is how they manage distributed caching. This does not really mean that the old caching methodology is gone. This is one of the options available to you in 2013. Social data is also cached. So we talked about activity feed. Before we can talk about a lot of things in terms of feed LMT cache, etc. Let's look at this diagram, which will explain, it's self-explanatory. So you have a lot of activities that are getting generated in social data, like for example, the microblog features. You have posts, you have replies, you have mentions, documents, etc. And then you have feeds basically that get generated. Now you have this distributed cache. So the data first goes in and sits into the content database as well as into the distributed cache. This is my last time of activity, modified activity cache that I have. So whenever my modified activity cache expires, which means the time expires, I'm going to be triggering this distributed cache to cache that data which is being sent by the activity generator. So which means the data that is accessed from the cache is going to be the latest data. So data accessed is whom you're following, likes, activity feeds, news feeds, mention feeds, site feeds. You have a lot of feeds that come into picture as far as. So you can go ahead and do some settings. There are some settings available as far as activity feeds are concerned. This has to be done obviously through PowerShell. So you can go and take a look at these settings like feed cache, TTLRs, last modified time, cache object count limit, room for growth, etc. Okay, so that's exactly how it works. Now that we have seen some of the areas where caching is implemented, how is this distributed caching logically done? So we are going to be looking at the architecture. So usually this is how this happens. So you have something called as a cache cluster, where you have different Windows services running under different servers. Each server is called as a server host, and they are all cache servers. Okay, the cache cluster configuration in terms of how many servers are there, etc., is stored in a content database. and the partial is going to be controlling this, and you have the application server which is going to be controlling communication with the cache. In this case, it's going to be SharePoint. So remember, in our example, the application server which is using the cache is SharePoint server, and the server which is hosting the cache is also SharePoint server. So that's exactly how it works. So typically, what all can we do in terms of App Fabric cache in the host? It can be installed. You can remove it. You should not be stopping it. As I said, going back to the server here, I should actually not be stopping this from the central admin. So you will have to remove. So stopping does not help at all. It's something that we need to look at. How is the logical architecture of App Fabric cache? So logical architecture basically looks at a cache host that we have. Each cache host has a cache which is going to be implemented across, which means if I am storing say data for a profile service, it will be some part of the data will be stored in cache host 1, host 2, and host 3. Remember, there will be no copies unless and until you look for secondaries. Again, as of now, secondaries is not implemented in SharePoint. We can also have cached regions. So cached regions are basically related caches. For example, if I'm looking at social data caching, it is a cached region which has caches related. For example, my cache, my activity, my site activity, and so on and so forth. So which means we are talking about related caches. This is what we call as cached region. So named caches are there. These are your named caches that we see here. So these are your named caches. Example, you have the default cache as well. So you have cached items, which means what is being cached exactly, like activity feed and so on and so forth. You have cached regions, you have cached hosts. Now let us look at some of the cache configuration details. So the first thing that we look at is cache name, which is the name of the cache. Time to live, which is when it's going to get expired. Cache type, that means here it means actually, are we going to store the cache by partitioning the data? Are we going to store everything in one place? So as of now, partition is the default value that is available. Do we have secondaries? That means if the cache is going to expire, can we go to some other place to get the data? If the server goes down, can I have a redundant data? So as of now, there is no redundant data that is possible. So you have minimum number of secondaries that also can be configured, right? So when we talk about expiry, so how are we going to expire the cache? Is it possible? Then we have a concept of eviction. So after the expiry happens, what are we going to do with the data, and how are we going to make space for new data? Eviction type is there. There's an algorithm, like least recently used is one of the algorithms to evict non-expired items. Expired items anyways goes off. Non-expired items, what do we do? Then notifications can be enabled for people who subscribe to cache, the servers who subscribe to cache can be done. This is a typical example of how a eviction takes place. This is my high watermark, which decides what is the highest memory that I can give for a particular server, for a particular distributed cache. What is the lowest memory I can give for a particular distributed cache? So when my cache is above the highest watermark, all the expired data will go out of the cache. So that my cache remains within the high watermark framework. When my low watermark framework, which means my low watermark is going to be the minimum. So when it goes above this low watermark, which you see here, we are going to be looking at what is expired. When it goes above the high watermark, which means it is more than the maximum level of usage of memory, then automatically we have to look at also going across non-expired item and removing them. So we use the algorithm which is LRU, or least recently used algorithms. Okay. Now there are different levels at which we are looking at actually going up and having some kind of configuration. So what are the levels we are looking at? We are looking at configuration at the first at the host level. Host level is who is it that's going to be hosting the cache. Then we also look at configurations at the cache level, and we look at configuration for individual caches. So So these are the different various level configurations, and we have the distributed cache configuration. Uh, so that is what we look at. So there are three levels of configurations that we look at as of the configuration is concerned. So rest of the details possibly later, because we I think is we are running out of time. We also need some time for question and answers. So maybe I will do a part two whenever possible, and also show you these configuration details. So the entire objective of this session was to basically get you introduced to understanding the entire architecture of why we require distributed caching and what happens in SharePoint 2013. Okay, so that's it from me. Lohit, over to you. You please let me know what needs to be done. Any Q&A we can answer. Do we have
Yeah,
time to answer?
just minimize your. Maybe you can just what you can do is just have your deck with your email ID or something if you have posted. Just share that particular slide
One.
maybe.
Instead of deck, I think I will just share immediately. So my email ID is going to be arunbalach at gmail.com. Okay, so this is my email ID. I do have a blog that I just created some time back. I have not filled in yet, so I'm planning to fill in my own blogs and sites, because I was really busy with my own consulting work as well as my training work. So I was not able to do it. So after some time, surely I'll also let people know my blog as well as my sites, which is already created using GoDaddy.com.
Yeah, just keep your email flashed as is, so don't open the Hangout window, otherwise it will go into a virtual maze. You can minimize the Hangout window and just have the notepad. You may want to just, if you can, just increase the maybe the font so that people can just see your.
Is it visible?
Yeah, just scroll down. Yeah, so this should be fine. Yeah, thanks, Arun. So it was a wonderful insight into caching and how the caching should be done, especially on a SharePoint level. I think one of the previous Hangouts we had Kamlesh and Raghavendra and myself, just doing a kind of a panel discussion on SharePoint, trying to understand better. So I consider SharePoint as a white elephant. It's huge. It's humongous. So caching does play a vital role in any part of the applications, like be it a normal ASP.NET or SharePoint. So it was a great insight into what are the different types are available, when to apply, and all those things. So thank you very much for a wonderful session. We don't have any questions. So most probably that's why I said, like, this is recorded live. So it's going to be available post this particular session. People will be able to watch this recording. It's going to be at youtube.com/, youtube.com/b.net TV, so they can go there. So thank you very much for a wonderful session, and then we hope we'll try to get you back sometime.
Thanks a lot,
And
Mohit.
for the rest of the folks, yeah, for the
Sure.
rest of the folks, have a good night and have a great week ahead. So we'll catch you on another hangout next week.
Okay.